So today we're going to learn the steps for solving problems. So I have here a problem we're going to look at. The problem says the volume of a regular rectangular box is known to be 36 m to the 3. That means meters cubed. The height is 6 meters and the width is 2 meters. What is the length? Okay, so I'm going to divide the page in half here so we can list the steps on this side and we'll solve it over here for you. So first thing we want to do when we're doing this type of thing is, if you can, so we'll say 1 here, if you can, draw a sketch of the problem. Sketch of the problem. That would be the first thing you'd want to do when you're working on these. Sometimes it's easy to draw the sketch, other times it's a little bit more difficult. So this one's pretty easy. We just have some sort of rectangular box, and it looks like this. So that's what I'm looking at. Always drawing a sketch, really going to help you out. All right, so the second thing we want to do is we want to write down our givens. And anytime you do a problem in physics, this is what Ms. Nielsen and I are going to look for. You want to write down the givens with the number, unit, and the symbol. That's going to be your key to doing these problems. So if I'm looking at this, so for number 2, what things am I given? Well, I'm given 36 meters cubed. So I'm going to write down 36 meters cubed. And now I want to tell myself, what symbol is that? Now, in this particular one, you may not remember, but I need to write down the symbol for volume. And in this case, it's just V. Now, I'm doing an example here that you can probably do in your head. I just want you to see what the whole thing would look like. So I wrote down the number, the unit, meters cubed, and the symbol. This is the symbol, okay? What else are we given here? We're given 6 meters. 6 meters up here, and that's the height, so we'll say H for that. And the last one that we're given here is 2 meters, and that is the width. So far, so good. So now the next thing we do, write down symbol of your unknown. Your unknown is what you're asked to find. What are you trying to figure out here? So for this particular one, the unknown that I'm looking for is the length. So I'm just going to say length equals question mark. So at a minimum, when you're doing these problems, these things you have to get down. And when you have those down, then you're going to be able to go and answer these questions more easily. Our fourth thing is we want to write down our equation. Write down your equation. Okay? What equation are you using here? And again, I picked something here that I think everybody is familiar with. At least I hope so. Maybe you're not, and that's okay. But to figure out the volume of a regular box type thing, the equation for that would simply be volume equals length times width times height. Length times width times height. So we always want to make sure we're writing down the relationship that we're using. A lot of students will try to cut corners here, but when we're asking you to do a problem, once you get in the habit of doing this, which we're going to require, life's going to get so much easier for you on these types of problems. So the next step is, if needed, rearrange for your unknown. So I say if needed. If this question had asked you, what is the volume, and this is your equation, I wouldn't have to rearrange that because volume's all by itself. But in this case, I'm looking for the length. The length is with some other things here, so I need to get length all by itself. And to do that, I'm going to do this one here in 2 steps because I'll use the equation I have here. To get L by itself, I'm just going to divide both sides by the width and the height. So width and the height both cancel. And then I can rewrite my equation the way I want it, which means the only thing left over here is the length equals volume divided by width times height. There are going to be students that are going to say, I can do this in my head. I picked a problem that you can do very easily right now in your head, but these are the steps you want to do. So once I'm done with that, two more things we need to do, and this is the one that's going to cause the most problems, and it's probably the most important thing here. Check the units to make sure they make sense. Check units to see what you get. Okay, so in this particular case, the units that I want, well, I want a length here, so these things should end up giving me a meter all by itself. So I'm going to do my step 6 here on the side, and all I'm going to do here is put in the units I have. Volume, well, the unit on volume was meters cubed, so I put meters cubed on top. I'm just checking units now, and on the bottom I have my width. My width was the unit was just meters, times the height, which was meters. So we look at this, I have meters times meters times meters on top, and I just have meters times meters on the bottom. So these 2 meters is going to cancel out with 2 of the 3 there, and I am left with just meters, so I know I set up my problem correctly. And then the final thing, put in numbers and solve. So the last step here in number 7, I'll do it in a different color so it stands out. I would say length equals 36 meters cubed over my width, which was 2 meters, times 6 meters. Okay, we already know our units are going to work. And then 36 divided by 6, well, that's 6. And then 6 divided by 2 is 3. And we get our answer that we were looking for.
Thanks, Mr. Willauer, for that breakdown of problem solving. Next up, we're talking about the wave equation. So you might remember the wave equation from your web quest 2 weeks ago. It also has a different name. On the web quest, it was referred to as the traveling wave relationship. And what it gives us is a relationship between a couple different terms. It tells us the relationship between wave speed, frequency, and wavelength. So without further ado, I'm just going to give you that equation. The wave equation is as such. It is V is equal to F times lambda. And we'll go over what all of those things mean right now, but go ahead and write that down in your notes with a big box around it. Now, V stands for wave speed. V is our variable for wave speed. We know wave speed is measured in meters per second. It's also known as wave velocity. That's why it's a V. Frequency is our variable for F. F is for frequency, and we know frequency is measured in 1/seconds, or more formally, hertz. A hertz is a 1/second. So frequency is F, our variable F, and is measured in hertz. Finally, this last letter there that you see, it's a Greek letter, but it stands for wavelength, and it is the, we measure it in meters. Remember that from last week. But this letter that's kind of how you draw it. It's sort of an upside down Y, but it is the Greek letter lambda, or the Greek letter L. They didn't use W because W is used for something else in physics, so wavelength is used with lambda as our variable lambda, and it's measured in meters. So that is kind of the general wave equation. Take note that frequency is multiplied by wavelength there. There's kind of a hidden multiplication sign in there. You can draw that. But we're going to talk about what the relationship actually is between these 3 terms here now. So this is our wave equation, but how are things related? Really what we care about is this frequency-wavelength relationship. So in the equation, frequency is multiplied by wavelength, and they are on the same side of the equation. So since they're on the same side of the equation, they have a special relationship called an inverse relationship. So they are inversely related, which means that as the frequency is increased, then the wavelength is decreased. The wavelength goes down as the frequency goes up. Also, as the wavelength is increased, then the frequency is decreased. So that's what an inverse relationship is. As one goes up, then the other goes down. So they're inversely related. And again, we know that because they're on the same side of the equation across from wave speed. So as one goes up, the other has to go down, just because of how they are situated in the equation. Another helpful thing for us to understand our wave equation is to look at the units. So our wave equation is wave speed is equal to frequency times wavelength. So if we break it down in terms of units, we know that our velocity, or our wave speed, is measured in meters per second. So meters per second has to be equal to the unit for frequency, which is hertz, times the unit for wavelength, which is meters. So how is this true? How is meters per second equal to hertz times meters? Well, remember, frequency is also measured in 1/seconds. It's the same thing as a hertz. A 1/seconds is a hertz. So if we use that unit instead, we find that our velocity, meters per second, is equal to our 1/seconds times meters from our wavelength. And there we can see, if we do that multiplication, what we've got is meters over seconds. Right, 1/second times a meter is a meter over seconds. So all I'm doing here is just proving to you that this is a valid equation, right? That meters over seconds from our wave speed is equal to meters over seconds, which comes from our frequency, 1/seconds, times our wavelength in meters. So that's just one way we can kind of evaluate the wave equation. Another thing we have to talk about in this video is the frequency period relationship. So we kind of mentioned this last week, but remember, frequency is the number of cycles that are completed per second of a wave, and the period is the number of seconds it takes to complete a cycle. So we mentioned this last week, but the relationship that we kind of see is that these two are reciprocals. And what we can really see that if we look at the units. So remember, our units for frequency are hertz, or 1/seconds, and our units for period are just seconds. So you can see that those two are reciprocals of each other. Seconds, the reciprocal of seconds is 1/seconds. So how would we write this in an equation? Well, if they are reciprocals of one another, then frequency has to be the reciprocal of period, and or period has to be the reciprocal of frequency. So these are two other little equations that are pretty much the same one of each other, just written differently. Remember that F is our variable for frequency, and this T is a new variable for us. It stands for period. Again, not sure why they didn't choose P, but they chose T instead. So we're gonna go ahead and make that note up there, that period, its variable is T, and remember that our variable for frequency is F. So again, this equation, frequency, or F, is equal to 1 over the period, 1 over T, or the period T is equal to 1 over the frequency F. So again, those two are just reciprocals of one another. So you're going to need this wave equation and this period frequency relationship to tackle some of the problems that we are doing in this next example video.